I'll just turn on the light here now, Dave.
Thank you very much, Owen. It's great to be here in Ashford Castle, my first time. What an amazing place. We love going around the country to talk about the universe. And what else could be more important to reality than the nuts and bolts of what makes up our universe? You may know some of this already, so I'm going to do a whistle-stop tour of the universe with an Irish slant to it. And I've got about 20 minutes to cover everything that exists. I've got to get on with it. I'm so glad for the introduction. I was
Easy challenge.
so glad that Owen didn't introduce me by saying from one clown to another. So here's our talk. If I can find the later one. This is our magazine. This is what keeps me up late at night producing Astronomy on magazine. And the good news is, especially with the night that's in it, there's a copy of our magazine for everybody in the audience. So help yourself to the November issue. This is an old issue on my slides here. But I write the bit about what to see in the sky. So if you get the magazine, there's so much to see. If you go out tonight, it's clear. I spotted it briefly on the drive down. The moon has the planet Jupiter just beside it. And they'll actually be close tomorrow night as well. And these are the two brightest objects in the night sky. Fantastic sight to get people interested in space. On page 22, I always tell people, as soon as the magazine drops you in your letterbox, read the highlights box even before you rush out to work or school, and it'll tell you about big highlights to see in the sky. Most of them with the naked eye, and that'll bring the reality of the universe home, which is what we like to do in Astronomy Ireland. Forget about all the science and maths and figures. Here's I think it was October last year, the space station, which actually is in evening skies again. Skipped ahead there. I'm looking for the International Space Station is flying over every night, just a few minutes after 6 this evening, different time tomorrow night, and every night till December 5th. 7 astronauts on board, and they're experiencing a whole different reality, weightless in space for about 6 months. I won't dwell on the magazine. These are the kind of pictures we love to put in it. This helps me explain how the Irish invented space exploration. And this is Newgrange, that many of you know, built over 5,000 years ago. So we're talking 1,000 years before the pyramids, roughly 1,000 years before Stonehenge. People were studying the stars. It's a lovely picture where the camera sat on the Earth with Newgrange, and they've rotated once every 24 hours for about an hour and take those lovely star trails. And you know, they built this 200,000 ton monument with no metal tools. It's the Stone Age. So this is probably like us today with modern machinery, building all of a major town, if not a city. So why did they spend so much of their effort doing this? Well, we think it's because, this is just a little pet theory, that they were celebrating what they discovered about the universe to date, 5,200 years ago, which is that if you watch where the sun rises, you can do this yourself over the next few weeks, you'll see it rise at a certain point from wherever you live, and tomorrow or the next clear morning, it'll rise a bit to the right, a bit to the right, and that'll keep happening to the longest day of the year. And then the sun won't rise any further to the right than that. You could mark it in the ground with 2 sticks. And then after that, it rises to the left. So they were able to determine the exact start of winter. And I wonder, 5,000 years ago, think of what's happening. 15,000 years ago, the reality of the situation was there was about 1 kilometre, 1,000 metres, 3,000 feet of ice above this castle. Only the top peaks of the highest mountains in Ireland stuck out above it. 15,000 years ago, the ice cap receded. Ireland became habitable by plants. And about the same time, civilization was beginning in the Middle East. They discovered a thing called agriculture, which I think is more important than fire or the wheel. Because if you're a hunter-gatherer going around eating food off the land, chasing down wild animals, it turns out if you farm all that, you can sustain 100 times more people on the same patch of land than you could as a hunter-gatherer. And that catapulted civilization in the Middle East to start with, where it's nice and warm most of the time. And then the peoples moved north, and they've discovered something in Ireland that was very important to the people in Newgrange, which is a thing called winter. And you can imagine they arrived in Ireland, they had a few mild winters, and everything was great. They had enough crops. They've noticed the crops didn't grow in the winter like they do in the Middle East. But then they had one of the harsh ones like we had in 2015. It was minus 15 Celsius, and that would have killed everybody. They weren't ready for that kind of thing. They hadn't experienced this in the Middle East where they came from. So maybe decades or centuries went by and new settlers came. And they lasted a few mild winters. And then they had a harsh one. And they all got killed. Until maybe one day, and this could have taken thousands of years for all we know, some very clever spark realized that trick of watching where the sun rose. Realized that you could tell the start date of winter to within a day or two. And then you could count the number of days in the year. So the Irish weather, where we often have 4 seasons in one day, you could now decide when is the best time to plant crops to build up a store for any of those harsh winters that came. Whoever figured that out must have been the Isaac Newton, Albert Einstein, Stephen Hawking of their time. And so I'd like to win the audience over by suggesting that we're descended from the most intelligent people on the planet, back 5,000 years ago. And Newgrange is a phenomenal monument to that discovery, that we think they even knew that there's not just 365 days in the year, but 365 and a quarter, because they would have been counting them for centuries, and if they didn't allow for that quarter every century, that adds up to 25 days, which is a whole month. You don't get your crops wrong by that much. So then we skip forward. Oh, not that fast though. Oh, no sneak previews. It's a hair trigger for any of our future speakers coming up. Here we are in 1845, start of the famine, but also the building of the biggest telescope in the world. By now, humans had figured out, there's 365 days in the year because we go around the sun. But what are all these fuzzy patches out there in space? What's the reality of that? Well, they noticed as they built bigger and bigger telescopes, some of the hazy patches you can see through a telescope get resolved into stars. So some of them must just be further away, and if we build a big enough telescope, we'll eventually be able to resolve even the most distant objects. But some of them were resisting this, so they must be made of stars incredible distances away. And so in 1845 they were wondering about galaxies, or they called them back then island universes. We use a different phrase today. Galaxies, huge star cities. And so here we were, 1845, still leading space exploration, studying the skies from this island. That's 5,000 years of history we can be proud of. There are other stories in between as well, which back this story up. And you might be able to see it. If you haven't visited before, you have to. There's 2 people about the size of that pointer standing next to this telescope. It's wide, it's longer than this room is wide. I could walk down the tube without hitting my head off the inside of the tube. Now, unfortunately, you can't really look through it. I've looked through it once at a special event, but you can watch it moving up and down and beautifully restored about 20 years ago. Definitely worth a visit. And people are using this to figure out the reality of the universe is the important thing for tonight's talk. And then we skip forward to something more whimsical in this century, which is the Iron Man movies. I was a big fan of them. And then I found out that the screenwriters wrote Tony Stark, the character inside, based on Elon Musk. Now, I know Elon's got a bit of a bad reputation on some of the things he gets up to, but the important thing for me is he was a kid interested in space. He got sidetracked by computers and set up this crazy company called PayPal and sold it for $1.3 billion, like you do. But he went back to his space interests. And this is still one of his big interests, SpaceX. He built a space company, nearly went bankrupt trying to do it, but now he's launching more satellites than anybody else. And he's followed by a guy called Jeff Bezos, you might have heard. So these are the 2 richest people in the world. They're both kids interested in space who set up computer tech companies, but then spend their money going back to space. And they've stood on stage, the 2 of them together, saying they're going to put 1 million people on Mars in this century. Now, nobody's been to Mars. Nobody's even been to the moon since 1972. We hope that'll change in about 3 years. So maybe he's a visionary. Maybe he's got other problems as well. I leave you to worry about that yourself. But I like it for him for the space interest. And the fact he was a kid inspired by space. And here he is when he was in Ireland. I missed the opportunity to go on a pub crawl with him because I didn't know about his space interest back then, about 10 years ago, during the Celtic Tiger. But there he is talking to take me to your leader, Enda Kenny, a local man, who I hope he was explaining to him, we've got all these tech companies in Ireland building computer chips, pharmaceuticals and internet companies. Wouldn't it be a great place to build a space company? There are already 3,000 jobs in Ireland supported by the space industry. And so to get out into space, to show you what's out there, and where he might send you to work one day if you're lucky enough. This is the Earth, and I won't tell you all the millions and billions in space. You'll just forget them. You can look them up later on. We'll compare everything to the Earth. The Earth's important because it's mostly covered by water, and that's what you and I are mostly made of. We think we've evolved from life in the oceans, that single-celled organisms somehow decided to band together instead of eating each other and collaborate. And now you and I are 40 trillion cells, basically specialized microbes, bacteria, working together to make a human being. A being that's sentient, that can understand its place in the universe and contemplate reality. So it's an incredible story. I won't go into detail, other than say water is important. Our cells in our bodies are little packages of water, lots of complicated chemistry going on inside that we've brought with us from the oceans. So if we're looking for life elsewhere, we look for water. So here's our solar system, which we know quite well because we've sent spacecraft there. The sun I'll come to in a second. The four inner rocky planets, they're fairly small. The Earth and Venus are about the same size, the biggest. And the four giant planets, the gas planets in the outer part of the solar system. Freezing cold out here, very far from the sun. Then we've got little Pluto, an anomaly we now know. And of course comets, which we think are very important to human life. Let's have a look at the sun. It's a star, like all the stars you see in the sky. The difference is it's 1,000,000 times closer than the nearest stars that we see. So it's very important to us, powers all life, weather and everything else on the Earth. It's a huge nuclear reactor. About a quarter of its diameter is under such pressure, because it's 100 times wider than the Earth, that the hydrogen atoms it's mostly made of, and hydrogen atoms are the most common thing in the universe. They were created in the Big Bang. About 3/4 of the universe is hydrogen, 1/4 is helium, the rest, a tiny percentage, is all the other stuff that we're made of. That's important to us, not important to the universe. And so it's crushing atoms together and driving the temperature up to 15 million degrees Celsius at ridiculously high pressures that we can't reproduce on the Earth. And if we could fuse atoms together, which doesn't produce as much radioactive waste as the nuclear reactors we have at the moment, which split giant atoms apart. That's a fission process. So the sun, all the stars in the sky work the same reason. They're so big that the atoms at the center get squashed. The Earth's not big enough, even the giant planets are not big enough, but stars are. And here's the sun. This is actually a spacecraft picture. They've got a selfie stick here covering the sun so it doesn't blind the camera. They've drawn the size of the sun on it. And it repeats every few seconds. It was the year 2000 when a massive explosion happened on the sun. You see it coming out as a halo. So we're looking down the gun barrel. 2 days later, that radiation, billions of tons of it, hits the Earth and causes an amazing display of the Northern Lights, which you rarely see from Ireland. I've seen them 2 or 3 times this year in Ireland, up in the north, inside the Arctic Circle, where I've lucky to have been a few times. You see them every night, because the radiation is directed by the Earth's magnetic field into the north and south poles. So that's the sun. Then we get to the planets. Mercury, 3 times closer to the sun than we are. If Elon Musk or Jeff Bezos offers you a job on this planet, don't go. It's 400 degrees Celsius where the sun beats down overhead. That's hotter than your oven at home. The next planet is Venus, twice as far from the sun as Mercury, so it should be cooler, but it has a greenhouse gas atmosphere. We're worried on the Earth. We've got about 1 part in 2,000 of the air we're breathing is carbon dioxide. And look at the trouble that's causing. On Venus, it's 95% carbon dioxide. So the greenhouse effect is shot through the roof. The temperature shoots up to 500 degrees Celsius, and it's only 2/3 of our distance from the sun. So it's a lesson for us as what not to do with our planet. We weren't able to see the ground on Venus, so we sent spacecraft there, and here's a radar picture. By bouncing radar waves off the surface, we could pick up all the surface detail and strip away the clouds. We said not many craters. Rocks from space haven't bombarded Venus and left their mark like they did on Mercury or the Moon. And we think what happens is water is very important as a lubricant on the Earth. We have a molten core, thin crust on top, made of several plates that can slide around relative to each other. As they slide around, they cause pesky volcanoes to us humans. Don't change the planet much, but it allows the heat, radioactive heat from inside, to slowly escape. On Venus, it's too hot for water. The plates set solid. It's like welding a pressure cooker shut. Over millions of years, the temperature slowly builds up and eventually blows its top, and resurfaces the entire planet. All the volcanoes go off at once. We think these are volcanoes on the surface of Venus, now extinct, and they'll go off again in a few 100 million years and resurface Venus. We definitely don't want that happening to the Earth. And here is the Earth, third planet out. The first one with a big moon, our moon. One thing the ancient astronomers figured out was there are 12 full moons most years, so they divided the calendar up into 12 months. That's where we get the word month from. We've seen the Earth enough. On to Mars, where people might one day be able to eke out a miserable existence. It's probably the equivalent of living in the Arctic Circle or even the Antarctic. It's freezing cold, but it can get reasonably warm during the day. This is a spacecraft picture, but it looks similar to what Mars looks like through giant telescopes. It's got an ice cap. These blue wispy things are clouds, and dark patches. And dark patches they thought were vegetation in the 1800s as they built bigger and bigger telescopes. Because this ice cap melts in the Martian summer, the clouds thicken, the dark patches get darker. Plant life would explain that. And some astronomers thought they could see thin lines crisscrossing the surface, and that was evidence for intelligent life. We now know it's not that. Whoops. Well, let's go to the sneak preview. H.G. Wells wrote his famous book in 1898, The War of the Worlds, which has been made into countless dramas, including one by Tom Cruise and Steven Spielberg in 2004. And when he did it, this was the biggest grossing movie Tom Cruise had ever made. So he owes his career, another famous Irishman by the way, to Mars and space. But get back to the story of the life on Mars. We now know the dark patches are bare rock. The light patches are sandy deserts. The winds change direction in the seasons of Mars. So it's just the sand being blown on and off the rock. It's not plant life. It's a pretty barren surface. We know there's water below the surface. Whether life got started on Mars and managed to eke out a miserable existence, that's what we're trying to find out at the moment. Maybe it didn't get started. Maybe it went extinct. Maybe it's still there below the surface, struggling along. And it has two moons going around it, Phobos and Deimos, very small. They're asteroids that came from the asteroid belt. We sent a spacecraft out to Jupiter. It's the first asteroid ever photographed, called Gaspra, named after a spa town in Ukraine on the Black Sea. So when they got close-up pictures, they decided they'd name all the craters after spa towns around the world. So Bath, Spa itself in Belgium. And this one up here is Lisdoon Varna. So I gave this talk in Ennis once, and it was great to be able to tell them there's Lisdoon Varna up the road, and there's another one out in space. And then we get to Jupiter, the giant planet. Definitely a place you don't want to go. It looks very warm and inviting on these pictures, but if you were to touch the surface or the cloud tops, they're at minus 130 degrees Celsius. So you could snap your fingers off one by one, but you wouldn't be able to do that because the radiation would kill you in minutes. So if you're offered a job on Jupiter, no thanks. It has over 90 moons going around it. Io, Europa, Ganymede and Callisto, about the size of our moon, a bit bigger. And they're made of slush, not rock, so that's water and rock mixed together. And on Europa in particular, we think that the gravity of all these things pulling on each other has flexed the planet, warmed it up, and so the rock is sunk to the bottom. There's a 100-kilometre deep ocean on top of that, and an ice crust on top of that. And that's twice as much water as in the Earth's oceans. And it's warm, so if we're right about how life got started on the Earth, it should have happened on one of the moons of Jupiter at least. The Great Red Spot's a huge spinning storm, 500-kilometre-an-hour winds, going for centuries, not like the few days that we get storms here on Ireland. So a really crazy planet. Jupiter's 11 times wider than the Earth. Saturn's 9 times wider, nearly as big, and the moon got too close and got shredded into billions of boulders to make those brilliant rings. It's got over 140 moons. These are the 6 biggest ones. Titan is as big as the planet Mercury, has a nitrogen atmosphere same as the one you're breathing now, only it's minus 180 Celsius. And when you look at that sheet of rings close up, you see it's rings within rings, each one being individual boulders following each other in orbit around Saturn. Uranus and Neptune are the 2 outermost planets, very hard to see. You can see Jupiter tonight, as I said, near the moon. Saturn's the other side of the moon, not as obvious. Uranus and Neptune, you need binoculars. Going around Uranus, though, it has 27 moons. This is my favourite, Miranda, about the size of Britain and Ireland. But something smashed this moon apart and caused these beautiful, oops, what did I press there? These beautiful ice cliffs, which are 10 kilometres high. Can you imagine the view? 10 kilometres of sheer ice on this moon where the sun is just a bright star in the sky. Neptune has some dark spots on it, and a moon going around it called Triton. This green stuff you can see is a nitrogen atmosphere like the one you're breathing now, only it's frozen solid on the ground as green ice. Pluto we now know is not a planet. Here's a spacecraft picture we took of it, showing the lovely heart-shaped ice, probably glacier feature on Pluto. Fascinating planet, but right on the edge of the solar system. And when you look deep out into toward the sun, you see the sun's just a bright star in the sky on the edge of the solar system, and Jupiter and Saturn, even the big planets, are just bright stars. Comets, I said, were important because this is one that fell toward the sun in 1997, Hale-Bopp. It was an extremely bright comet, and we think that early on comets bombarded the young, hot Earth and filled the oceans with water. So 2/3 of our body is made of water. Half of that could be from comets. So we might be actually 1/3 comet juice. Humans. There's Halley's Comet, which we sent a spacecraft in to photograph the actual dirty snowball, 15 kilometers long, 8 kilometers wide. And just to finish, we can't get out to the nearest stars. It's 6,000 times the distance to Pluto to get to the first star to the sun. So we have to build giant telescopes. Here's one I visited in Australia, Portakabin, the astronomer sitting. They used to actually sit up in the cage here before digital photography. And it takes pictures like this, the Orion Nebula, a huge cloud of gas and dust that falls together under its own gravity, maybe nudged by an exploding star. Here's the baby stars inside, the 4 brand new stars. All this red stuff you can see has been blown away from the screen, behind the screen, and this dark tongue of material is being blown towards you. So it's hollowing out its own place in space. And you see this makes fantastic pictures, I think are better than most works of modern art. The Trifid Nebula there. Eventually you end up with a cluster of stars and the gas and dust being blown away, and a little naked cluster of stars on its own made from that gas cloud. One of these would have been our sun 4 billion years ago. Going around and any dust got swept up into the planets. But eventually the sun will die. It can't keep crushing atoms forever. This is the way we think the sun will die. With a bit of a whimper, the core cools down or becomes less active, and it boils off the outer layers into space. But giant stars explode with a bang. They get very unstable inside. This one was seen by Irish monks in 1054. The rest of the world didn't really record it, but the Irish did. And it's still exploding today, 1,000 years later. And we think these giant explosions give us all the big atoms that we need, like zinc. If there's no zinc in your body, you die. That wasn't made in the Big Bang. It was made by giant stars that exploded before the sun was born. And all these stars live in giant star cities. Here's one we think looks like ours. Galaxy, 500 billion stars swirling every 200 million years. Bit of a bar and a black hole at the centre, slowly gobbling them all up. That was the view from above. Here's the view from the side, just to show you that it looks like 2 fried eggs clapped back to back. Very unromantic description. And then when we look out into deep space, we see the universe is teeming with galaxies. The famous Hubble Deep Field. There's about 1 trillion stars in every galaxy, a million, and there's about 1 trillion galaxies in the universe we can see. So there's a million stars in the known universe. And where it all come from, just to end, a Big Bang. A tiny point in space expanded extremely fast for 1/trillionth of a second, and has been coasting ever since. Something seems to be pulling it apart faster and faster. If you think there's a crazy story, it's all backed up by science and evidence, facts and reality. And in fact, the mathematics that explain the Big Bang are the same ones that make your smartphones work, this laptop, any solid state electronics. So it's something inescapable that we know roughly how the universe got started. Where's it going to end? You might want to ask me that later on. We have some ideas, but we don't know. It's a crazy universe, I think. Us sitting here on a rock, going around a star that's orbiting a galaxy that's in a space-time that's stretching faster and faster and may one day rip itself apart in the future. That's been my story. I hope I haven't gone over time. Thank you very much. We take Q&A later on, yeah?
Yeah.